videos for the lesson 5.4 homework. Kenny makes me question why I ever became a teacher. Number 1, what is the name of a line that is approached and may or may not be crossed? What is it? Your favorite word. Asymptote. Killing me. All right, what's the name of the y-coordinate of a point in which the relation crosses the y-axis, meaning the x-coordinate equals 0? Y-intercept. All right, we are doing domain and range of real world. So we got to think what can actually happen in the real world. All right, an experiment with a virus started with 5 infected cells. The number of infected cells grows at a rate of 20% every minute. What is a reasonable domain and range? Well, first off, we've got to be able to write this as an exponential function. So, is it growth or decay?
Growth.
It's growth. Okay. So, what's our A value? What's our initial value? 5. And then our rate is 20%. Now, that is not our B value. Your B value, when it's growth, equals 1 plus the rate. But I cannot do anything with a percent. Does anybody know how to turn a percent into a decimal? Okay. How I taught 8th graders, tried and true, pretend like that percent sign. Can y'all see the 100 in that percent sign? Here's the 1, here's a 0, here's a 0. That's how I taught 8th graders to do it, tried and true, because they didn't always count. They would want to make like 5% into 0.5 instead of 0.05. So, when in doubt, make it a fraction, put it over 100, type it in your calculator, and that'll do it. So, 1 plus 0.2 is 1.20, right? So, our function f of x equals 5, 1.2 to the x. All right, so now we're going to look at it and see what it looks like. All right. Here we go. 5. That was what algebra was doing. That was up there. Y'all shouldn't panic at all. All right. So here's what my graph looks like. So what does the x-axis represent? Well, what are the x's? So what are the x's? But in this real-world problem, what are they? Cells, right? The number of cells infected. What's y?
No, it's the infection. Each one that gets infected. It's the grow rate.
It's the minutes. So, if these cells are infecting more cells every minute, so the y-intercept there at 5, that's what we're starting with. At 0 minutes, we got 5 cells infected. And then at 1 minute, that's the number, or, wait, we did that backwards. We did it backwards. Y is the cells, X is the minutes. Whew. Make sure we know what we're talking about here. All right. So, domain, X. What's the smallest amount of minutes we can have? 0, right?
Yeah.
What's the greatest amount of minutes we can have?
5. Well, infinity.
Infinity, right? If this thing keeps running, it's going to keep making cells. What's the minimum number of cells that we can have?
5.
5. Now, the reason it's 5 is because the minimum minutes is 0. Time can't be less than 0. So we have to start, and you can pull that up on the table when X is 0, and C. And then what's the maximum number of cells we can have? Infinity. Keep going. All right, so here we go. Verbal description. All real numbers. Greater than 0 or greater than or equal to 0?
Oh,
Equal to, because minutes can be 0. That's the start point. Minutes, 0 is a possible. So, greater than or equal to 0.
I just put the
Greater than or equal to 0. All right, so then what's my range going to be?
All real numbers.
All real numbers.
Greater than 5.
Greater than or equal to? Or equal to 5. All right, so now we've got our basis. We can start. So how would I write this? Greater than or equal to 0 as an interval. What's my first number going to be? 0. Bracket, because greater than or equal to gets a bracket. Infinity, what kind of
You need a
parenthesis? Okay. What about this one? What's it start at? 5.
to infinity.
Bracket to infinity.
not bracket.
A not bracket is called a parenthesis. Okay. How do I write that as an inequality?
Whoa.
Now why?
X is all real numbers. Oh, is that not this one?
Not yet.
Greater than or equal to 0.
So alligators eating who?
The X.
Line underneath,
Yes.
and then
0.
0. Bracket, it gets a line.
And then do we do the XER thing?
On this one, you don't have to.
Okay.
So range. Okay. All right. Here's where you put it all together. So X with a line. X is a member of the set of all real numbers where X is greater than or equal to 0. I can't wait till cubics. Cubics, we do unions. Our domain and range are unions. All right. Y is a member of the set of all real numbers where Y is greater than or equal to 5. I feel like it's getting easier for y'all because this is what, the 4th time we've done domain and range like this?
Yeah.
I just don't like verbals.
Well, I normally help you with the verbals. All right, so hey, let's write the expression or the equation for this one. Yeah. But we've got to have a function first. All right. So a rubber bouncy ball is dropped from a height of 120 inches onto a hard, flat floor. After each bounce, the ball returns to a height that is 20% less than the previous maximum height. What is a reasonable domain and range for the function? Growth or decay?
Okay.
Okay, decay, so we're going down. What's my A value? 120. What's my rate?
20%.
So as a decimal?
0.2.
0.2. All right. Decay, to get your B value, is 1 minus R. 1 plus R for growth.
1 minus
1 minus R.
So it's gonna be 0.8.
No.
No, just 0.8.
0.8.
Negative.
And then X.
1 minus 0.2?
Yeah. Oh.
If I have $1 and you take 20 cents away from me, I still have 80 cents. So our function f of x equals 120, 0.8 to the x. Here's a way you can tell from the function if it's growth or decay. If this number is less than 1, it's decay. If this number is greater than 1, it's growth. So that's one way you can always tell if you did it the right way. All right. So here we go. No. All right, 120 times 0.8 to the x. Oh, I can't see anything. Menu 4. Whoa.
No, I didn't.
I'm going to start telling coaches. Well, at least I know that's going to make a difference in your little life if I go and talk to a coach.
That make difference in Mark's life.
Now I'm going to tell Coach Seago I want to make him run.
Either they don't make Mark run right now. You got a hand.
You got a hammy? Well, we'll ice that bad boy, numb it up, and then you can go take a couple laps. All right, here we go. Hey, on this story, what does X represent?
X represents the
Inches.
Yeah.
It represents height.
Or does it
Why is the high?
Or each bounce.
Y is the height. X is the bounce number. All right, so what's the smallest number of bounces we can have?
0.
0. That's where it starts. What's the biggest number of bounces we can have? Infinity. Okay, what's the ooh.
The height's 120 feet. The highest. Or inches.
Is that the
That's the highest.
that's the highest. Okay. So the highest it can go is 120. What's the lowest it can go? But can it ever reach 0?
1. No.
No. You can't.
It can never reach 0 off of the bounce.
They don't know. I don't know.
Okay, this is an exponential.
If the bounce hits 0, then
Okay.
If it's 0, that means it didn't bounce.
Y is greater than 0.
Okay. 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 So our domain is from 0 to infinity, right?
Yeah.
So all real numbers greater greater than 0. Range. So from 0 to 120, but can the height be 0? So all real numbers greater than 0, so not greater than or equal to, and less than, can it be equal to 120? Less than or equal to 120. So I know you're thinking it's eventually going to stop bouncing. The height off the ground is eventually going to be 0, and you're right.
Yeah, but the highest, but it can only go, it can't go 0.
It wouldn't be a bounce anymore. Does
Yeah,
that make
that's
sense?
That's what I'm,
The experiment ends, so there wouldn't be an X to go with it.
yeah.
We don't know where that point is, so we just call it at it's never going to get less than 0. Okay? All right. The 3 different forms, that's all you've got to write. Watch your signs, because you've got 2 different signs here. This is going to be a double.
I think we should do this one.
No, I need you to do it.